Good evening, everyone. Today I will present the outline of my review paper, which entitled Recent Advances in Pectin as Natural Emulsifier, and how the pectin molecular structure and functional component will impact pectin emulsifying properties. So this is the table content of my introduction. So first is introduction. In introduction, I will define emulsifier and also pectin. And the second section will be pectin as emulsifier. Third section will be the molecular structure of pectin. So from here, I divide into two. First is chemical composition, which is further divided into three: degree of esterification, degree of acetylation, and protein content. The second part is structural composition of pectin, which is divided into two: homogalacturonan and rhamnogalacturonan 1. And then the fourth part is application of pectin emulsifier, as mentioned below. And last part will be conclusion. So first, I will explain about emulsion definition. So what is emulsion? Emulsion is a liquid preparation containing of two immiscible liquid, one of which dispersed as globule in another liquid. So as you can see here, immiscible liquid is two liquid that cannot be mixed together because it has different polarity. So from here, the dispersed phase will be put into continuous phase. And as you can see in the third picture, it cannot be mixed together. So here comes the function of emulsifier. So emulsifier, emulsion, we have two types. The first one is water in oil emulsion. The second one is oil in water emulsion. So water in oil, the dispersed solution will be water, we'll be putting into oil, and oil in water is oil we'll be putting into water solution. And then here are the definition of emulsifier. So emulsifier is generally amphiphilic molecule, consists of both hydrophilic and hydrophobic end. So the hydrophilic part will be attracting to the water molecule, and then the hydrophobic tail will be attracting the oil molecule here. So first, when we mix water and oil, it cannot be mixed, right? But after we put emulsifier here, the emulsifier will bind both hydrophilic and both hydrophobic together, and it will lead to stable emulsion, and the emulsion will no longer be separated. So here, if we just mix it, the emulsion won't be stable. So normally, to make a stable emulsion, we have to use homogenizing process. So homogenizing is a process where the dispersed phase is broken into small oil droplets. And normally we utilize using high pressure homogenizer. And then normally emulsifier is divided into three types. The first one is synthetic, second one is semi-synthetic, the third one is natural emulsifier. So the synthetic emulsifier, the example as here, mono and diglyceride, polysorbate and lecithin. So the mechanism here is the same as what I explained before. The hydrophilic part will be facing water and lipophilic part will be facing oil, and then it will bind together and then disperse into small molecules. But the disadvantage of using synthetic emulsifier is it could affect the gut microbiota, which possibly leading into inflammation and metabolic disorder. For semi-synthetic emulsifier, the example are methyl cellulose, hydroxypropyl cellulose, and methyl cellulose derivatives. Why is it being called as semi-synthetic? Because normally the cellulose derivative, we use harsh chemical solvent. So that's why it is like semi-synthetic emulsifier. So the mechanism is the same with the synthetic emulsifier. But the advantage here, despite their viscosity enhancing properties, it has limitation in stabilizing certain emulsion system. And their application also could be impacted, could be limited by factors such as pH and temperature. And then the third one is natural emulsifier. Example here is normally polysaccharide from polysaccharide source, such as tragacan, agathia, agar or chondrus, or pectin and starch. So the mechanism is similar as the other two, but the disadvantage here, since mostly of the natural emulsifier were derived from carbohydrate source. So it is a good medium for the growth of microorganisms. Therefore, we have to put some preservative in order for the natural emulsifier to have more longer shelf life. And then here goes the introduction for pectin and emulsifier. So pectin is defined as biopolymer composed of dimethyl polygalactoronan chains with 300 to 1000 galactoronic acid linked by C1 to C4 glycosidic connection. So here, what are the advantage of pectin over another emulsifier is first, pectin has diverse versatility. Pectin can help to stabilize a wide range of emulsion, including oil in water and water in oil. The second advantage is pectin has various health advantage. It can decrease cholesterol by binding to cholesterol and bile acid, and also improve digestion and enhancing gut health. The third advantage of using pectin is a biodegradable polymer. So it is easy to oxidize by the microbe. And while also it can reduce the environmental impact compared to synthetic emulsifier. So normally pectin, they are derived, they have three types of structure. The first one is Hg, second one is Rg with sugar side change, and the third one is Rg2. And here, I describe the molecular structure of pectin and their effect of emulsifying properties. So the first part is degree of esterification. The second one, degree of acetylation. The third one is protein content. So how does degree of esterification impacting? First, I will define the definition first. So degree of esterification is fraction of carboxy group esterified with methanol or other alcohol in pectin. So as we can see from the picture here, the first one, if DE is more than 50%, we classify it as high methoxypectin. And if DE is lower than 50%, we classify it as low methoxypectin. So if you can see here, the methyl group is more than low methoxypectin. So this is a high methylpectin. It has more methyl group compared to low methylpectin. So here, the more higher DE means more methyl group is present. So more hydrophobic group is present. This hydrophobic group able to deposit at the oil-water interface. It able to attract more oil droplet and it result to more stable emulsion. So significant here, higher DE influence higher gelling properties and emulsifying properties of pectin. So the mechanism here is higher DE increase molecular coiling, enhance molecular mobility, and facilitating faster absorption at oil-water interface. And then the second one is degree of acetylation. So degree of acetylation is defined as proportion of galactoronyl residue esterified with acetyl group. So normally pectin, they have DA ranging from 40 to 85 in pectic polymer. So here is the acetyl group binding into the pectin structure. So the effect here is this acetyl group, the same as the group before. It increased the hydrophobic properties, making it suitable to be used as interfacial agent in all water system. And it also can maintain and by thickening and increasing more gelling capabilities of pectin. But from the study that I compiled, it's been observed that pectin that has DA more than 10%, only the pectin that has DA more than 10% has significant effect on emulsifying ability. So there's few studies that observe pectin less than 5%. Actually, they don't give any significant effect. So actually, I think from my compilation of study, I think actually DA does not give that much influence on pectin emulsifying properties compared to degree of esterification. And here, the emulsifying properties from one study, they say that acylated citrus pectin exhibit more better emulsifying properties than non-acylated pectin. This is probably due to the reduction of calcium-induced flocculation. And then the third part is protein content. So normally, RG1 type of pectin, they do consist of some protein. This is the protein content binding into pectin structure. So the protein content here able to interact with oil and water because they have both lipophilic and hydrophilic end. So they're able to bind with the oil and water interface. So this protectionist component adhere to emulsion droplet surface, resulting in significant reduction and hereby facilitating more effective emulsifying properties. And then the third part is structural composition of pectin and their impact on emulsifying properties. So here I divide into two. Actually, pectin has three types. First is homogalactronan. Second one is rhamnogalactronan 1, and the third one is rhamnogalactronan 2. But there's no study on rhamnogalactronan 2 in impacting emulsifying properties, so I remove from my slide here. So I will first be discussing about Hg pectin. So Hg pectin is defined by pectide polysaccharide that comprise of linear change of 1,4-link alpha D galactronic subunit. So as we can see here, it has mostly consists of galactronic acid with rhamnose and also methyl ester. So in here, there are three factors in governing the properties of emulsifying. So the first one is depolymerization, the second one is deesterification, the third one is amide substitution. So what is depolymerization? So as we can see from the picture here, depolymerization is we cut the pectin molecule into small molecular units. So we can use three types of depolymerization process. We can cut the molecular weight by using backbone hydrolysis or beta elimination or either decarboxylation. And deesterification is removal of ester group. So ester group, we have two here, either methyl or acetyl. So we have in deesterification, they remove the methyl and acetyl group here. And for the amide substitution, we introduce the amide group in pectin structure. So as we can see here, the amide group is being conjugated into pectin structure, CONH2. So I will be explaining one by one. The first one is depolymerization. So as I've been mentioned before, depolymerization is we cut the longer molecular weight into smaller molecular weight. So in here, there's one study by 2019. It observed that citrus pectin was depolymerized using alkaline solvent, and it showed good centrifugation stability compared to conventional and enzymatic extraction. This is because the stability was being enhanced due to the reduced molecular weight from beta elimination process during alkali deesterification. So this beta elimination, it degrades the pectin structure and it improves their emulsifying capacity. The second study, they observed lower molecular weight speed up the absorption of emulsifier to the droplet surface, and it stabilized newly formed droplet in more faster way. It is being observed in this study by Myers 1999. It observed depolymerized pectin with molecular weight below than 80 kilodalton demonstrate effective emulsion stabilizing properties compared to native pectin. So the conclusion here is shorter change with lower molecular weight of pectin, it lead to more better emulsifying properties. The second one is deesterification. So as I mentioned before, deesterification is we either remove methyl or acetyl part from the pectin structure. So the first study is alkaline deesterification of pectin was being done by Liang et al. So in this study, it showed that after they removed the ester group, it weakened the gel properties and emulsifying properties of high methyl pectin. So this, after they remove the high methyl pectin, this result in weaker entanglement, and this lead into lower emulsifying properties of pectin. The second study, it is the opposite way. They increase the DE, and after they increase the DE, the emulsifying properties is improved due to enhanced coiling phenomenon in pectin molecule. So this effect is expected to enhance the molecular mobility, leading to faster absorption at all interface, and consequently, it leads to higher emulsifying properties. So the conclusion here is higher DE has better emulsifying properties than lower DE. And then the third part is amide substitution. Amide substitution is we introduce amide group in pectin structure. So in this study here, the pectin amidated with glutamic acid, glycine, and lysine. They amidated with 3 types of chemical here. So this amidated pectin from these 3 chemicals, they exhibit significantly higher emulsion activity compared to native pectin. However, study by Shua et al., it showed the opposite trend. Amidated pectin show lower emulsifying properties. So the conclusion here, actually the influence of amidated group is depend on the pectin structure and also pectin type, also the extraction method. So we cannot conclude here either amidated pectin has better emulsifying properties or not, since the trend will be differ for each pectin source. And then this is the second type of pectin, RG1. So RG1 is comprised of a core structure consisting of alpha-1,2 link aramnose and also alpha-1,4 link electronic acid with future side chain. So as we can see here, it has more side chain sugar attaching to the pectin structure. So normally the rhamnose here, the rhamnose blue color, it will attach to different type of sugar side chain, and also it also will be attached with the ferulic acid and also protein. So in RG1, the factor governing emulsifying properties derive from change length, and the second factor is from the side change. And then the first one, change length. So from few study, it been noted that longer RG change provide better coverage and stabilization of oil droplet. So this lead to the improved emulsifying properties of pectin. So this statement is being supported by this study from Zhang et al. So in this study, they observed pectin from pomace. They have longer change of RG1. So longer change means they will have larger side change, and this larger side change allow to create more and stronger intra or intermolecular bond. So this bond will lead to more complex and tight local network on the droplet surface, and it will lead to the better emulsifying properties of pectin. So the conclusion here, longer change of RG1 pectin will be having better emulsifying properties. And then the second factor of RG1 is their side change. So as I mentioned before, ferulic acid and protein also can be add higher to the pectin side chain. So in the first study conducted by Zhou et al., they observed that superior emulsifying properties from sugar beet pectin is determined by its protein content and contribution of ferulic acid. So sugar beet pectin is RG1 pectin because they've been classified because they have rhamnose and other sugar side chain. So sugar beet pectin also, among other pectin, they have highest protein content actually. So in here, the impact of ferulic acid were further explored by Liu et al. So Liu, they explored the mechanism by varying the ferulic acid content in different type of pectin. So the combination of both pectin and ferulic acid, it enhanced the emulsifying by providing robust steric stabilization effect, and this will prevent oil droplet coalescence, and this one, it will contribute in better emulsifying properties because ferulic acid able to anchor onto the droplet surface through its affinity to the oil phase, and it increase surface coverage and ensuring greater steric stabilization. So in short, this mechanism lead to better emulsifying properties. So here the conclusion is presence of protein and ferulic acid, able to improve the emulsifying properties of pectin. And then the last section of my review paper will be regarding on the application of pectin emulsifier in food industry. So I divide into 4 applications. The first one is beverage. So normally pectin emulsifier is being added to stabilize the emulsion, prevent separation, and also improve the mouthfeel. In dressing and sauce, pectin emulsifier help to provide more smoother and creamy texture. It also helps to prevent oil and water from separated. And it also can improve the overall stability of the product. In confectionery and baked good, pectin emulsifier able to improve texture, mouthfeel, and shelf life. While in ice cream and frozen food, it also the same. It able to improve the texture, and you also can fill in the gap between the biopolymer. So this will prevent more ice crystal formation and provide more smoother and creamy mouthfeel. So in conclusion, the emulsifying properties actually influenced by various factors, and more study is further needed actually. So from my compilation of reading, I've been noticing the trend that govern the emulsifying factor of pectin. The main one is degree of esterification, degree of amylation, protein content, and molecular weight. However, the side chain also, protein moiety, ferulic acid, and acetyl group also were found to be having a major role in pectin emulsifying properties. So overall, pectin is a versatile and effective emulsifier that can be used in food industry to improve the food texture, stability, and overall quality of food and beverage products. So why do I write this paper? Because our lab project now are focusing on the last year of our lab project. We are focusing on applying pectin or crop pectin as a fat replacer. So that's why I've been writing this in order to enhance more, widen our lab area. So that's all for me. Thank you. Okay. 질문 받으세요.